All right, assignment 2.5. It's about extrema and the mean value theorem and some review. What is the absolute maximum? So we're looking for the y value. So that answer up there is 3. These are going to be easy questions to begin with. Enjoy the easy questions. What point does the function reach a global minimum? So what's the lowest point on the graph? That's 5 and negative 2. At what x value does you have a relative minimum? So at 0, there's a relative minimum. Where else do you have a minimum? Here, we have a relative minimum here at the x value being 4. And we have another minimum for the x value being 5. The fire marshal just came in to check my fire extinguishers. That's why. 4. They were quiet about it. At what x value does the function have a relative maximum? So we have a relative maximum here. The x value there is 1. And that's it. There are no more maximums on this graph. Number 5. That was simple, right? Enjoy the simple. Don't forget to do the simple correctly. Find the critical numbers of these. And that's it. Just find the critical numbers. Don't do anything with them right yet. So to find the critical numbers, we take the derivative. We look, is there anything that would make this undefined? No. Make it equal to 0 and then solve it. So we have a critical number at 3/2. Number 6. Take the function. So step 1 is to take the derivative. So 2/3 times 6, that's 12 divided by 3, and then subtract 1 to the exponent. Sometimes it's easier to write this algebra friendly so that you can see what the restriction is. So if I write it algebra friendly, you can see that 0 is a critical number. I'll do that right here. 0 is a critical number because 0 makes the derivative undefined. Make it equal to 0 and solve it. We're going to cross here. So we have 2 root x is equal to 4. Divide by 2. And then cube both sides. And you get 8. So 8 is also a critical number. Do that right? Yeah. So here. So the two numbers were 0 and 8. 0 makes it undefined and 8 makes it equal to 0. 7. Take the derivative. This is a line. There are no critical numbers on a line because it never turns. There's no maximums or minimums on a line. It goes in one direction forever. There are no critical numbers here. So there's nothing that makes it 0 and there's nothing that makes it undefined. There's just no critical numbers on a line. 8. When you see absolute value in calculus, you're going to have to graph it. So to graph this, I'm shifting it 2 to the left. And then I draw it. And the derivative is undefined at negative 2. So that's a critical number because the derivative is undefined because it's a sharp corner. Number 9, I love trigonometry. You should say that every time so you don't get frustrated. So take the derivative here. So first take the derivative. There's a hook. So 2 times 1 in front, subtract 1 to the exponent. Then the derivative of cosine is negative sine. The derivative of sine is cosine. Make it equal to 0. We're going to factor out a cosine. And then we're going to solve it. So first of all, if cosine is 0, then the two angles that give you 0 are pi over 2 and 3 pi over 2. That's here and here. The x values are 0. That's what cosine is. The second one, we're going to solve it. So I'm going to subtract 1 and divide by -2. So that's 1/2. And so where is the y value 1/2? And so that, its partner is root 3 over 2. So that's a 30-degree reference angle. That's over 6. So one angle would be pi over 6. And because it's positive 1/2, the other one would be 5 pi over 6. So those are all the critical values. Knowing your unit circle, practicing, not giving up, telling yourself that you love trigonometry and trying to work through it. Number 10. In number 10, without a calculator, it says to find the absolute maximum or minimum and show organized work using the candidate test. Sometimes we do a table of values to organize it. So the end values, I'm going to plug in for a table of values and then evaluate it. So that's 1 and 3, so I think that's 4. This is 25, take away 15, so that's 10. And then we did this, remember on the last question, x squared minus here, what were the only critical number is 3 over 2, or 1.5. So if I plug 3 over 2 in there, I get the answer, -9 over 4. Sometimes you have to earn it. Common denominators. So it's 9 take away 18, so it's -9 over 4. And then what is the absolute max? That's 10. What's the absolute minimum, the lowest y value? And that's -9 over 4. Using calculus. Number 11. Again, these are functions we already did before to find the critical numbers, but now we have end points. We have ends of the interval that we have to consider. So I'm going to do a table of values to organize it. So I'm going to first start with -1 and 27. The critical number we already found in that case was 0 and 8. Now I'm not going to use, 0 and 8 are on my interval, so it's all good. And so I already did the work here. Now I just got to plug in and find the lowest y value and plug in and find the greatest one. So if I go -1, this is going to become +1. So 6 times 1 is 6. And a negative times a negative, all of that gives me the answer 8. 27. So the cube root of 27 is 3. 3 times 3 times 3. So it's 3, and 3 squared is 9. So we got 6 times 9 minus, so it ends up actually being 54 minus 54. So that answer is 0. Zero gives me the answer 0. And then the last one's 8. So the cube root of 8 is 2. 2 squared is 4. 6 times 4 is 24. Take away 16. And so there's nice symmetry here. So it's pretty obviously what the absolute maximum is 8 and the absolute minimum is 0. Looking at these numbers. Here we go. Number 12. Number 12 was not done above, so I have to do all the work for number 12. Here we go. Step number 1, we're going to do a table of values, and we're going to use the end values first. So that's -27. That's +9 times 3 is positive. That gives me the answer 0. If I plug in 1, I get 1 plus 3, and I get 4. You need to work on your mental math skills to get it correct. Next, I'm going to take the derivative. There's nothing that makes it undefined, so I'm just going to solve it, make it equal to 0. Factor out, or you can divide out a 3, but factor out a 3x. And so one answer is 0, and the other answer is negative 2. Notice 0 and negative 2 are in my interval, so they all work. So you have to double check here to make sure those answers are in my interval. 0 gives you the answer 0. Negative 2 cubed is negative 8. Negative 2 squared is 4 times 3. This is 12, take away 8. So again, some nice symmetry here. So the absolute max is 4, and the absolute minimum is 0. Done. Number 13. Same question. I shouldn't have done that one, but the interval is different. So I'm going to come back and make sure what I tossed away, I'm going to look at. So 13 has the exact same function, but the interval changed. So the interval is now from negative 1 to 1/2. So I still need a table of values. I need negative 1 and 1/2. But the critical numbers I found before, I got to make sure they're in my interval. So 0 and negative 2. In this situation, I'm only going to use 0 because negative 2 is not in my interval. So negative 1 gave me the answer. Well, I hadn't done negative 1. So negative 1 is negative 1 plus 3. 0 gives me 0. 1/2 cubed is 1 over 8. 1/2 squared is 1/4, so that's 3/4. So that's 7 over 8. So the absolute max is 2, and the absolute minimum is 0. Oops, there it is. Number 14. Now I'm going to check. Now it's the mean value theorem. So in this case, at x equals 0, there's a sharp corner. So the MVT does not apply. Is not differentiable because of that sharp corner. So this does not apply. So it must be continuous and differentiable. Number 15. This is both. A polynomial is always continuous and differentiable. So that's good. That works. So I need to know the derivative. I also need to know the AROC. And then I'm going to make them equal to each other. So if I plug in 3, that's 9, take away 6. If I plug in 1, that's 1, take away 2. So if I simplify it, it's 4 divided by 2, which is 2. So now I take the AROC and I make it equal to the derivative, and then I solve it. So the C value, where the AROC equals the IROC, the answer is 2. Number 16. The first thing I look at, is it continuous and differentiable? It's a polynomial, which means it's both differentiable and continuous. It works. The derivative, and then the AROC, and then I make them equal to each other. So if I plug in 2, that's 4, take away 6, plus 2, that's 0, right? And 0 divided by 0 is 0. And then you take that, equal to the derivative, and then solve it, and you have your answer. So that's the C value. 3 over 2. Alright, 17, just give me the last one for this video, then I'll do part 2. for the second half. This graph looks like this. There's a cusp or short corner at 0. You could also see it algebraically. So if you took the derivative and you made it look right, so if you make it algebra friendly, you can see 0 makes the derivative undefined, so the MVT does not apply. All right, Mr. G Math over and out. I'm proud of you for doing your work. And now on to part 2.